Dear students, today we are going to start chapter 5 Trigonometric functions of R.D. Sharma. Exercise 5.1. Prove the following identities. Some identities are given, we have to prove them. For proving the identities, we can take left hand side or we can take right hand side. Choice will be ours. But which side we have to take? The side which is looking lengthy or complicated, then take this side. So other side we can get easily. If suppose both the sides are looking same, so we can take any one side. Suppose we are taking left hand side and after simplifying we are not getting the right hand side. In that case, we can also take the right hand side and after simplifying we will not get the left hand side, but the values of left hand side and right hand side will be equal. In that case, the identity will be proved. So this is the way of proving the identities. So here question number first, sec raised to the power 4x minus sec square x is equal to 10 raised to the power 4x plus 10 square x. This we have to prove. Both the sides are looking equal, so we can take any one. So I am taking this left hand side, taking LHS, sec raised to the power 4x minus sec square x. We have to prove this is 10 raised to 4x plus 10 square x. So here sec raised to 4x minus sec square x, we have to convert them into 10 raised to 4x plus 10 square x. So for converting sec into tech, for converting sec x into tan x, we have identity since 1 plus tan square theta is equal to sec square theta, or shift this one this side. So tan square theta is equal to sec square theta minus 1. So for changing this, sec raised to 4x minus sec square x, in both the sec square x is common, so first take out sec square x common. Sec square x common, here sec square x left minus 1. Now for converting this sec into tan, we have the identity since 1 plus tan square theta is equal to sec square theta. So therefore tan square theta is equal to, shift this one, sec square theta minus 1. For converting this sec square and sec square x minus 1 into tan, we can use this both. Sec square theta is equal to 1 plus tan square theta. So replace this sec square x by 1 plus tan square x and replace this sec square x minus 1 by tan square x. So sec square x, we can write 1 plus tan square x into sec square x minus 1, we can write tan square x. Multiply this tan square x in both the terms. 1 into tan square x plus tan square x into tan square x, 10 raised to the power 4x. We can write this 10 raised to the power 4x plus tan square x, which is equal to right hand side. Question number second. Prove that sin raised to the power 6x plus cos raised to the power 6x is equal to 1 minus 3 sin square x into cos square x. Here, this left hand side is looking complicated because the power is 6. So, taking left hand side, LHS is equal to sin raised to the power 6x plus cos raised to the power 6x. Here, this sin raised to the power 6x, we can write sin square x whole cube plus cos raised to the power 6 can be written cos square x whole cube. Here we can apply the identity a cube plus b cube. So recall the identity a cube plus b cube is equal to a plus b into a square plus b square minus ab. This identity we can apply here. Here a is equal to sin square x and b is equal to cos square x. So a plus b, a is equal to sin square x plus b is equal to cos square x into a square sin raised to the power 4x plus b square means cos cos raised to the power 4x minus ab minus sin square x into cos square x. So here this sin square x plus cos square x is 1. We have the identity since sin square theta plus cos square theta is equal to 1. Here in place of theta angle is x. So this sin square x plus cos square x will become 1. Now we have to simplify this sin raised to 4x plus cos raised to 4x minus sin square x cos square x. So one more identity we have. First write this sin raised to the power 4x as sin square x square plus cos raised to the power 4x can be written cos square x whole square minus sin square x into cos square x. One more identity since a square plus b square is equal to a plus b whole square minus 2ab. This we can apply here. So this is a square, this is b square. So we can write a plus b whole square minus 2 times ab, which is equal to a plus b whole square sin square x plus cos square x. This is whole square minus 2 times ab. A is equal to sin square x, b is equal to cos square x minus this term as it is minus sin square x into cos square x. Simplify this. This sin square x plus cos square x we can write 1. So 1 square minus 2 sin square x cos square x minus 2 sin square cos square x we can write minus 3 sin square x into cos square x, which is equal to 1 square 1 minus 3 times sin square x into cos square x, which is our right hand side. Question number 3rd. Prove that cosec x minus sin x into sec x minus cos x into tan x plus cot x is equal to 1. So taking left hand side, LHS is equal to cosec x minus sin x into sec x minus cos x into tan x plus cot x. Now here different ratios cosec, sin, sec, cos, tan, cot. So convert all these ratios in terms of sin and cos. After converting into sin and cos, we can easily get this right hand side 1. So this cosec x we can write 1 upon sin x, because the reciprocal of cosec x is sin x and reciprocal of sin x is cosec x. So cosec x is equal to 1 upon sin x minus sin x as it is. In second bracket sec x can be written 1 upon cos x This sec x is reciprocal of cos x minus cos x as it is into, in third bracket, tan x is equal to sin x upon cos x plus cot x is equal to cos x upon sin x. Now we can simplify all these brackets. Take LCM. Here in first bracket, LCM is sin x. So 1 minus sin square x. In second bracket, LCM cos x. 1 minus cos square x. In third bracket, LCM sin x into cos x or cos x into sin x. Sin x into cos x. Dividing by this cos x cancelled, multiply the sin x into numerator. So this is sin square x plus divide by sin x cancel, cos x into cos x, cos square x. Now we have the identity since sin square theta plus cos square theta is equal to 1. So this identity we can apply. Here sin square x plus cos square x will become 1. Here 1 minus sin square x, shift this sin square x this side, so 1 minus sin square x we can write cos square x. Here 1 minus cos square x, shift this cos square x this side, so 1 minus cos square x can be written sin square x. So change all this. 1 minus sin square x cos square x upon sin x into 1 minus cos square x is equal to sin square x upon cos x into sin square x plus cos square x is equal to 1 upon sin x into cos x. Multiplication signs here, so we can cancel the terms. This cos square x and cos x cancelled. This square and this sin x cancelled. In numerator, cos x left into sin x left. And denominator also, this sin x into cos x. We can cancel them also. Cos x cancelled, sin x cancelled. So here, which is equal to 1, and 1 is our right hand side, is equal to right hand side. Question number 4. Prove that cosec x into sec x minus 1 minus cot x into 1 minus cos x is equal to tan x minus sin x. So this side is looking lengthy, so take this left hand side. Taking LHS is equal to cosec x into sec x minus 1 minus cot x into 1 minus cos x. This we have to solve for getting tan x minus sin x. So here cosec x, sec x, cot x and cos x. So we can convert them into sin cos. Again, by converting them into sin cos, easily we can get this tan x minus sin x. So cosec x can be written 1 upon sin x. This is the reciprocal of sin. Sec x can be written 1 upon cos x minus 1 minus cot x can be written cos x upon sin x into 1 minus cos x as it is. So all the ratios we converted into sin cos. Now simplify them. 1 upon sin x as it is. Take LCM in this bracket. LCM of cos x and 1 is cos x, so it is 1 minus cos x minus cos x upon sin x as it is into 1 minus cos x. Now we can write this 1 minus cos x upon sin x into cos x. In this way we can write this minus this we can write cos x into 1 minus cos x upon sin x. So whenever the somethings are common, then first take out the common. After taking common, the sum will become very easy. So this 1 minus cos x here and 1 minus cos x here. So we can take out this factor common, and denominator sin x, sin x. So take out common 1 minus cos x upon sin x. After taking this common, what is left here? Here this out and this sin x. So 1 upon cos x left here. In first term 1 minus cos x upon sin x common. So 1 upon cos x left minus here this bracket and this sin x outside. So only cos x left. Cos x. Now simplify this further, which is equal to 1 minus cos x upon sin x. In bracket take LCM. LCM of cos x and 1 is cos x. So 1 minus cos square x. This 1 minus cos square x. This is 1 minus cos x. And 1 minus cos square x we can write sin square x. By this identity, sin square theta plus cos square theta is equal to 1. So 1 minus cos square theta, shift this cos square theta this side. 1 minus cos square theta is equal to sin square theta. So 1 minus cos square x is equal to sin square x. And upon this sin x into cos x. Now this square and this sin x, because we can write sin square x as sin x into sin x, so one sin x we can cancel. Now here 1 minus cos x left into sin x upon cos x. So for getting this tan x minus sin x, just multiply this sin x upon cos x into this bracket. So what will happen here? Sin x upon cos x, this we can write tan x, and this cos x into sin x upon cos x. Cos x will be cancelled and we will get sin x only. So which is equal to sin x upon cos x minus cos x into sin x upon cos x. So this cos x gets cancelled. Here sin x upon cos x can be written tan x minus sin x. This is our right hand side. Tan x minus sin x. Question number 5. Prove that 1 minus sin x into cos x upon cos x into sec x minus cosec x into sin square x minus cos square x upon sin cube x plus cos cube x is equal to sin x. So taking left hand side, 1 minus sin x into cos x upon cos x into sec x minus cosec x into sin square x minus cos square x upon sin cube x plus cos cube x. equal to sin x we have to prove. So here we can apply the identity a square minus b square, here a cube plus b cube, and convert this sec and cosec into sin cos. So this 1 minus sin x into cos x upon this cos x. Sec x can be written 1 upon cos x minus cosec x we can write 1 upon sin x into sin square x minus cos square x we can write sin x plus cos x in one bracket into sin x minus cos x. Here we used a square minus b square. In denominator a cube plus b cube identity. A plus b sin x plus cos x into a square plus b square minus ab. So sin square x plus cos square x minus ab means sin x into cos x. So identities we applied here. Now this sin x plus cos x and sin x plus cos x cancelled, which is equal to 1 minus sin x into cos x upon this cos x, and take LCM in this bracket. So LCM is cos x into sin x or sin x into cos x. Cos x into sin x. Cos x dividing by cos x cancel, sin x into 1, sin x minus dividing by sin x, this sin x cancelled, cos x into minus 1 minus cos x into, in numerator this sin x minus cos x left, so write this sin x minus cos x, and denominator this sin square x plus cos square x will become 1 minus sin x into cos x as it is, sin x into cos x as it is. Here we applied the trigonometrical identity. Sin square theta plus cos square theta is equal to 1. Since sin square theta plus cos square theta is equal to 1, we applied this here. So 1 minus sin x cos x, 1 minus sin x cos x cancelled, which is equal to here this 1, and this cos x also cancelled. So here sin x minus cos x, and this sin x we can shift in numerator. So into sin x into sin x minus cos x only. So this sin x minus cos x cancelled. So finally only sin x is left here, which is equal to right hand side. So we proved this sin x. Question number 6. Prove that tan x upon 1 minus cot x plus cot x upon 1 minus tan x is equal to sec x into cosec x plus 1. So taking left hand side, tan x upon 1 minus cot x plus cot x upon 1 minus tan x. Question number 6. Prove that tan x upon 1 minus cot x plus cot x upon 1 minus tan x is equal to sec x minus cosec x plus 1. So taking left hand side, is equal to tan x upon 1 minus cot x plus cot x upon 1 minus tan x. We have to prove this equal to sec x into cosec x plus 1. So convert this tan and cot into sin cos first. Tan x can be written sin x upon cos x upon 1 minus this cot x can be written cos x upon sin x plus cot x cos x upon sin x, and this 1 minus tan x can be written sin x upon cos x. Simplify these two parts by taking LCM. In numerator, write this sin x upon cos x as it is. In denominator, 1 and sin x, LCM of 1 and sin x is sin x. So it is sin x minus cos x plus this cos x upon sin x as it is. In denominator, 1 and cos x, LCM cos x. So this is cos x minus sin x. So they are double fraction. So shift them, this sin x shift into numerator and this cos x into denominator. Similarly, cos x in numerator and sin x in denominator. So we can write this sin x into sin x sin square x upon cos x into sin x minus cos x plus this cos x into cos x cos square x upon sin x into cos x minus sin x. Notice here this bracket is sin x minus cos x and this is cos x minus sin x. So take out minus sign common from here so that it will become sin x minus cos x. So both bracket will be same. So we can take out commoner in LCM. We can take the same term. So sin square x upon cos x into sin x minus cos x, minus sign common, so this will become minus upon cos square x. So this is sin x, minus sign we have taken common, so cos x minus sin x will become sin x minus cos x. Now whenever the some things are common in the steps, so first take out the common so that this calculation work will become easy. So here sin x minus cos x, sin x minus cos x bracket is common in both. So 1 upon sin x minus cos x common. Now what is left here? Sin square x upon cos x, and minus here cos square x upon sin x. Now simplify this bracket, which is equal to 1 upon sin x minus cos x as it is. Here take LCM, LCM cos x into sin x, cos x into sin x, cos x cancel, sin x into sin square x, sin cubic x minus sin x cancel, cos x into cos square x, it will become cos cube x. Now we can apply here a cube minus b cube identity. What is the identity? a cube minus b cube. Since a cube minus b cube is equal to a minus b into a square plus b square plus ab. This identity we can apply here, which is equal to 1 upon sin x minus cos x in numerator, sin x minus cos x into sin square x plus cos square x plus ab. Ab means sin x into cos x. Upon cos x into sin x. We can simplify this. Now this sin x minus cos x bracket and sin x minus cos x cancelled and this sin square x plus cos square x can be written 1. This is Pythagorean identity. So which is equal to 1 plus sin x into cos x upon cos x into sin x. Here we applied this. Since sin square theta plus cos square theta is equal to 1. This identity we applied here. Now we have got this 1 plus sin x into cos x upon cos x into sin x. What is our right hand side? We need sec x into cosec x plus 1. So for getting this sec x into cosec x, divide this two terms. Divide this both the terms separately by cos x into sin x. So which is equal to 1 upon cosec x, 1 upon, which is equal to 1 upon cos x into sin x, cos x into sin x plus sin x into cos x upon cos x into sin x. So this sin x cancelled, cos x cancelled, here 1 left, and in first term 1 upon cos x can be written sec x and 1 upon sin x can be written cosec x, and this is plus 1, which is our right hand side. Sec x into cosec x plus 1. So I think it's enough for today. Remaining questions we will see in next class.